Hey, good morning, everyone. Welcome to, what is this, day 4 of Ignite? Get the right slide up there. There we go. So welcome to Microsoft SQL Server end-to-end high availability and disaster recovery. My name is Denny Cherry. I got some contact info on the screen. I got some business cards down here. The highlights are I've been doing this for a really long time. I'm a Microsoft MVP for the SQL Server product and a Microsoft Certified Master for SQL Server 2008 and 2012. And I'm the principal consultant at Denny Cherry and Associates Consulting.
I'm Joey D'Antoni, and before anybody asks, I was riding my bike Sunday about 2 hours before my flight, and this pedestrian was walking with traffic, and she did a 180, like right into me. So I broke my arm when I hit her, and then I fell off my bike and kind of got scraped up. But I'm highly available. I have 2 arms. So I'm also a principal consultant. Denny and I work together. I missed the Microsoft Certified Master program for SQL Server, but I'm a certified solutions expert for BI and data platform. And I'm also a Microsoft MVP. You can find me on Twitter at jdanton.
So here is how we've broken down the session for today. We're going to talk about always-on failover clustering. Then we're going to talk about always-on availability groups, and then we're going to talk about some of the new stuff in SQL Server 2016, if you haven't come by the booth to talk to us about that already. So before we actually get into the material, I always like to do a survey at the beginning of my presentations. So this is where you guys get to do a little exercise. So where are my DBAs? About a third of the room. All right, sysadmins. Okay, about another third of the room. Yeah. Developers. 12 poor souls.
What do the rest of you do?
Yeah. Well, hey, managers?
Managers, yeah.
Okay, so a third of the room doesn't work. Awesome.
Okay. Project managers?
People who think this is the line for Starbucks. Nobody, one guy. Okay, cool. And then, so is anybody running 2016 in TAP? Besides me and Joey.
Yeah.
Nobody. Okay, 2014.
Wow.
Really? All right, most of the room. Okay.
75%.
Yeah, 75% of the room. 2012. Almost everyone. All right. Okay. 2008 R2. This should be everybody.
2008?
2008.
Wow.
Well, okay, you've all upgraded. Awesome. 2005. This is where we get the hardcore people.
Wow, that was more than 2008.
That's more than 2008. Yeah. So 2000. That's a lot of people. That's like a tenth of the room.
10%, yeah.
So 7. A couple of people.
Hey, the guy hanging your head in the back, do you still have NT4O servers?
He's nodding his head, yes. Okay, so SQL 6.5.
No, can't be.
Everybody's tapping out at that point. Okay, that's not too bad. All right, I'm assuming you're just wiping your head, not saying yes for 6.5. All right, so let's talk about failover cluster instances. So SQL Server failover clustering is just built on top of Windows Server failover clustering. Obviously, we require the Windows failover component to make the SQL Server clustering work. That's where all the magic comes from. When it comes to SQL Server itself, it's basically just a SQL Server instance. It just happens to be configured to be allowed to run on multiple physical or virtual at this point pieces of hardware, Windows OSs. So the Windows OS gives us that redundancy. It allows us to move that instance of SQL Server from one box to another. I'm going to use physical terms, but you can do all this in VMs as well. So all we do is we simply take our SQL Server install and effectively just go, we've got this box over here. We simply build this second box and go, in the event that this box is going to fail, just move the instance here. And our failover instance time is going to be about 60 to 90 seconds typically. That's, and that's to get the instance back up. How long it takes for that database to come online, that's going to depend on a whole lot of factors, mostly how many transactions were in flight while that database failed over. So when you're setting up a failover cluster instance, you can set these up about as wide as you want. You can really do as many nodes as you want and as many instances on that cluster as you want. The official supported number is 25 instances per cluster. And the reason for that is we need one drive letter per instance up through SQL Server 2012. There's, in case anybody didn't catch that, there's 26 drive letters in the alphabet, in the US alphabet. That's what we use for drive letters. You need one for the OS, so that leaves you 25. Basic math. When you're setting these up, you have a single set of database files for your cluster, for your instance. So it doesn't matter which server we're running on. we always have just one set of files at the back end. So that's why we need some sort of shared storage to get these instances set up. So typically that's going to be SAN storage. If you're in a virtual machine environment, you're going to need to use either RDMs in VMware or
Hey, don't forget
iSCSI in the
vSphere 6. vSphere 6.
Oh, that's right.
Yeah.
vSphere 6, we can now use shared VMDKs,
Yeah.
I think is what they're calling them. Or, yeah, VMDKs. Yeah. So, there's a lot of options for getting these set up, and it's just a matter of how wide you want to set things up and how big things can go. Now, when we're setting up these failover clusters, a key thing to remember is we're not scaling our workload out. That instance only runs on one box at a time. So no matter how many nodes we throw at the cluster, if we throw, like, say, a 6-node cluster, that single SQL Server instance that we connect to, that's only running on that one box at a time. So if we need more horsepower, we got to buy bigger boxes and buy more cores to throw in that box. So the basic process looks something like this. We've got node A, we've got node B, we've got a single SQL Server instance. Obviously, this is a very simple configuration. We've got a network name at the top, which is going to be some sort of additional network name and IP address. It may or may not have an instance name. So you can either do this as a default instance or as a named instance.
And that's going to be an Active Directory virtual computer object for your virtual name.
Right.
Yeah.
So this is an actual computer object in AD. So you'll actually see it pop up when you do the SQL Server install. Down at the bottom here, we've got shared storage, like I said, of some sort. Now, starting in SQL Server 2012, we could actually use a network share as our shared storage location. So if we had a file server that was highly available already, we could use that file server as our shared storage target. Some systems that need really high I/O in a clustered environment, but they don't want to pay for 2 Fusion I/O cards and block-level replication software on that end, what they'll do is they'll put a single file server out there, slap a Fusion I/O card in it, or some sort of PCI-based SSD card, and then they'll use that network share as their target, as the network share that holds their SQL database files. And that actually works relatively well as long as everything's using SMB 3.0.
You have an animation.
Yeah. So in the event that it fails over, that's literally all that happens. The SQL instance just moves from one side to the other. The node that's taking over just simply takes control of the storage, takes control of the network name and the IP address, and then starts the SQL Server instance. I haven't heard this in a while, but I used to hear complaints all the time that SQL Server ran a lot slower when it was running under a cluster. SQL Server doesn't actually run under a cluster. All the cluster does is start the SQL Server service. It doesn't do anything special to it. The only difference as far as SQL Server is concerned between a standalone instance on a server and a clustered instance is that the network name that the SQL Server listens on is going to be this virtual name at the top as opposed to the physical server's name. That's the difference. There's no other difference in the EXEs, the DLLs, or any of the other components within the cluster. Now, I mentioned you can do a multi-instance cluster as well. So we can set up a really wide cluster as well. At this point, SQL Server supports a cluster as wide as the operating system supports that you're installing on.
64
So
nodes.
64 nodes
Yeah.
is the Windows 2012 R2 width. I probably wouldn't recommend that. It's going to take you 3 or 4 days to get all the SQL Server instances installed.
If you scripted them.
Yeah, if you script them. If you sit there and click next, you're going to be there for like 2 months. It's going to be insane.
We kind of chose these diagrams for a reason. These are probably the most 2 common customer scenarios we see. Single instance, Alan's going to hit me, but active passive. It really is active passive. Or this scenario, multi-instance, 3 instances, 4 nodes. These are probably the 2 most common scenarios I've run into.
Yeah, definitely. So here we've got just 4 nodes in our cluster, node A, B, C, and D, and then we've got 3 SQL instances sitting on top of them. So when you're setting up in a multi-instance cluster like this, you can only have one of these as a default instance, so without an instance name. 2 of them have to have an instance name. Little trick. If you don't like the instance name, even though you have to install with it, as long as you set these guys to listen on port 1433, when you go to connect to them without an instance name, they will still listen. They will still respond. Old trick, worked forever, not documented very well. We still have that shared storage underneath, so we have at least 1 drive letter for each of these instances if we're doing local-ish attached storage, SAN storage attached to the VMs.
So it's one thing to note with that. It's pretty important, or just from a management perspective, it's a lot easier if you use mount points, especially when you get into a multi-instance cluster. And if you're not familiar with volume mount points in Windows, all you're doing is taking a physical volume and mounting it as a directory under a drive letter. Typically, you want to have that drive letter to be its own mounted drive, so you'll take a 1 gig volume, make that your drive letter. Wasn't there some performance reason behind that?
Yeah, so when you're using mount points, each LUN that you present and mount as a separate mount point has its own performance characteristics. Yeah. So they're not all bound by whatever the performance of, like, say, the root of the drive is. So if you mount, say, an E drive and then like 3 folders off that, one for data, one for logs, and one for tempdb, each mount point has its own performance throughput because they're effectively their own drives at that point. Yeah. So you can get better throughput through one drive letter by using mount points than you could through just using one drive letter, one drive.
Yeah.
So there's a few requirements for actually getting SQL clustering set up. Each of these instances is going to be installed and managed separately from all the other instances in the cluster. And you've got to actually do the install separately on each node of the cluster. This is why it can take forever to set up a large cluster, because we're running the installer over and over and over again. So if I've got a 64-node cluster and I'm putting 60 instances on it,
64 times
64 times 60 is a whole lot of installs. So you've got to actually run the installer every single time, which is why you'd want to script this out and make your life much, much easier. Every instance you're installing requires a separate network name and a separate IP address. So if you're familiar with Windows failover clustering and have used it before, what you're basically setting up is what we used to call a resource group. Now we call it an application in Windows 2012. And that's being set up inside the failover clustering, and each SQL server gets its own, or each SQL server instance gets its own, so that every instance is its own entity unto itself, so it can fail over back and forth independently of all the other instances on the box or in the environment. And like I said, it requires at least one cluster disk if you're using local disk. If you're using network shares, then you've got a whole new set of configurations you can start to play with. So our instance, we need to think of the instance a little differently now, because the instance isn't necessarily on a box. The instance could be anywhere within this environment that we've now built, because we've got this clustered environment. So we need to kind of think about how this instance works a little bit differently, just because it's not going to be just this one little component hanging out there that we can easily deal with and easily conceptualize. It could be running anywhere. So we need to think more about managing that instance as this more global thing, especially when it comes to patching, because we need to think about how we're going to be patching these instances and how things are going to be failing back and forth through the patching process. If patching is done correctly, you could actually patch a multi-instance cluster and only have to take each instance down one time, because all you're doing is patching all your passive nodes, and then when you're finally done with all your passive nodes, you simply fail over your instances from one side to another, and then patch that one remaining node that was active and is now passive. So once you get the hang of it, it's really easy to get these things up and running and keep these things patched and current fairly easily without failing them over too many times. The mindset that will really screw you up when you're going through this process, though, is we need this instance running on this node.
Yeah.
If you end up working yourself into an environment where an instance must reside on a single node or on a specific node, all bets are off. You've now got no point in having the cluster. And I've worked in environments like this. I worked for a home finance company, and we had a couple of 2-node clusters set up, and we could only run the SQL server on one node. If we tried to run it on the other node, the application wouldn't work for some reason that I didn't understand. Because that was the dev team's problem, not mine. SQL was up. So if the instance only works on one box, then there's something wrong with your cluster. We need to figure that out. And in this particular case, they would never actually let me figure out what was broken. So as we are setting these things up, so that clustered instance has that same name no matter where we move it. It doesn't matter what box it's on. That name is the same no matter what. So that's kind of how we need to think about the instance. We set up dependencies within our clustering environment. And this gets really important if you add more drives later to understand how these instances have their dependencies set up, because you're going to need to go change those on the fly to add and remove drive letters later on. The big things to keep in mind is down at the bottom we have an IP address. The thing that's going to be dependent on that IP is going to be a network name, obviously. We're going to have some set of disks, one or n disks, and then we're going to have a SQL Server service that's going to be dependent on the network name and then all of the disks that are underneath it. Now, if you're using mount points, you'll also want to set up dependency trees between the root drive and all the folders that are mounted as drives on top of that, because otherwise things are not going to come online correctly, and the SQL Server is not going to be able to find access to its drives. Yeah. It's really fun when SQL Server comes up and half the databases are suspect, because it started half a second before the drives came online. And if things don't come up in the right order, things get very, very cranky.
I have a pretty good story about this, and it's my most popular blog post ever. I used to work for a large cable company in Philadelphia. You may hate them.
If you don't, you're not their customer.
And I came in. I was on an architecture team. I was no longer a DBA, but I came in one morning at 9:30, and my boss had called, and I was like, I didn't have a pager, so getting called was unusual. And he's like, yeah, our offshore overnight people deleted the cluster resource for cabletown.com. And I was like, oh, that's going to be a problem. So one interesting thing to note, this instance name can be rebuilt on the fly. So if you Google, I just deleted my cluster resource, what do I do now? You'll probably hit my blog. This is just a cluster resource. It's not the Active Directory object, which was my first fear, that the Active Directory object got nuked, but it didn't. So easy enough to recreate, but don't delete it. So what happens is you can get like some weird Kerberos errors, and people will think it's a security thing. It's not. Trust me. Yeah,
as soon as people see a security Kerberos problem, what's the first thing they start doing? Deleting stuff out of Active Directory. Now you've just made things much, much worse. So we've had some enhancements over the years in failover clustering. So starting in 2012, the big enhancements we got was multi-subnet failover. So this was probably one of the biggest improvements we've had in the failover clustering space, probably just about ever, because this gave us the ability to easily do geographically distributed clusters. We've been able to do them for a good long time, but our network admins hated us for wanting to set them up because we had to do stretch VLANs. Yeah. We had to have the same IP subnet in 2 different cities, which is, as I understand, very complex to set up.
And expensive.
Yeah. So I personally think it's really easy to set up, because I submit a ticket, and then like a month later, I have a stretch VLAN. It's awesome. Apparently the network guys don't leave the office for 3 or 4 weeks. So now we can do multi-subnet failover. We simply tell the SQL Server, or the failover cluster actually, that there's going to be an IP address in this city, there's going to be an IP address in this city. Because we got this, and the way Microsoft put this in, this actually allows for even faster failover as well of our SQL Server database, and more importantly, the application that talks to it. So we have this functionality built into the SQL Server 2012 driver that goes along with this functionality in the multi-failover subnet support, where it allows the application to connect to both IP addresses that could potentially be hosting the SQL Server.
And that allows even faster failover, even if you're in a single subnet. And I forget why, but it's in books online.
Yeah, it's something about how the ARPing works or something. Yeah. I don't remember the specific details of it. So what happens when SQL Server comes up and you've told it that it may have 2 IP addresses is it actually goes into DNS and registers both IP addresses in DNS. So if you went to a command line, just did ns lookup SQL Server name, you'd get both IPs back. So the application sees this, and it actually goes and connects to both IPs. Whichever one responds, that's the SQL Server. The one that doesn't, isn't. So it simply disconnects that attempt, closes that socket connection, and uses the one that worked. The nice thing here is when we do fail over to DR, our applications are able to reconnect to the database instantly, because they're already trying to talk to both IP addresses. So everything just works really, really flawlessly. So the other big change was the network storage support that I talked about earlier. So we can actually use a SMB3 network share to host our database files. I know it sounds like it shouldn't work very well, but it actually works really, really well. I've used it in several environments. We can install in Windows Core mode.
Does anybody run Windows Server Core?
Yeah. Anybody using Core mode?
Wow.
About 15 brave souls.
All of the users are here.
Yeah, all 15 people that use it are in this room. That's awesome. So yeah, Windows Core mode is really cool because it installs Windows without a GUI. So less things to patch, less things to maintain, a thinner operating system, and my personal favorite, more RAM for SQL Server.
Yeah.
I don't know if you've noticed, SQL Server likes memory.
Yeah.
Yeah. Just disable all the alerts about how much RAM SQL Server is using. Yeah. You don't need those. So we get a nice small footprint, and we can now actually install a cluster on top of that. So that's actually something very cool that was introduced. Another big thing, tempdb on local drives. This was huge for our SAN admins. Whenever we built standalone SQL servers, data files on the SAN, tempdb on local storage. Move into a cluster with high availability, oh crap, now we need to take all that workload of tempdb and stick it onto the array. So that's all really high I/O, it's really poorly performing storage, compared to what we could get with local disk with like a Fusion card or an IOS or an Intel card or something like that. So now we can actually do tempdb on local disk, data files for user databases and other system databases out on shared storage, and it all works really, really well. This works especially well if you're in G-series VMs in Azure.
Yeah. You
get that D drive that's free, that's all SSD-based storage. You can put your tempdb on that. You just got to put it in the root, or you have a job that runs on when the machine boots that creates the folder structure that you need. And then you can have all your tempdb on local storage, not out on the shared storage that you're replicating out in Azure. So talked about this for the most part. So we do, like I said, with the multi-subnet failover, we get 2 different IP addresses, one for each data center, obviously. When we're setting up the failover cluster, the Windows team introduced the concept of having an OR statement inside your failover cluster configuration. So normally, when you set up your dependencies, you're dependent on a network name and a hard drive and a hard drive and a hard drive. You go into the network name configuration, and you're going to see 2 IP addresses listed, but there's not going to be and. It's going to be the first IP address or the second IP address. How it figures out which IP address to use is just based on the IP subnet that the machine that it's starting on is sitting in. So if the machine is sitting in the 192.168.0.0 subnet, it's going to use the IP address that's in that subnet. Fairly straightforward.
The only other thing I'd add there is review the Exchange time to life docs, because I think they did a better job of documenting it than the SQL team did for multi-subnet failover. Because depending on how far apart your data centers are, you may need to adjust DNS time to life.
Yeah, definitely, because you could have things coming up, and especially if an IP changes somewhere. If you're using DHCP, things will get all over the place, and you could end up with machines over here trying to talk to IPs that just don't exist anymore. So in 2014, we got some additional new features. We got cluster shared volume support, so we can use all the new cool features that are available in Windows Server 2012 R2 and in Windows 10 Server. That's
now Windows 2016.
Sorry, Windows 2016. Apparently, we didn't get all our slides updated since Monday when they changed everything on us. This is the 3rd year in a row Microsoft has changed everything right before my presentation. It's awesome.
Clustering supports cluster-aware updating, right?
Yeah, so failover cluster
clustering
instances support cluster-aware updating, yes, in Windows Server 2012 R2. If you're going to use cluster shared volumes, obviously you do need SMB3, but that's easy because you're on Windows 2012 R2 or above. So if you're going to do failover clustering in Azure VMs, infrastructure as a service, this is fully supported as of April 1st of this year. That was not an April Fool's joke. This does require third-party storage replication software. Currently, there's only one storage replication software that's certified to work in Azure. Sios Datakeeper. It's actually in the Azure Marketplace. So you're doing a single instance per cluster. You can only do 2-node clusters in Azure. Well, you can do more than 2 nodes, but you can only put 1 instance on that node. That's due to some of the networking requirements within Azure. You can also only do a single instance per cloud service that you have configured within your Azure account. So if you're going to have more than 1 instance, you're going to have more than 1 cloud service available, which is easy. Just create a new one. They're free. And you have to configure and use the internal load balancer. There's some really good documentation, some blog posts out there by David Birmingham. If you want to get this set up, he's gone through and documented the entire process. I've used it several times. Works great. Just requires a little bit of understanding of how Azure is working under the covers to make things work correctly.
So always-on availability groups. How many of you are using always-on availability groups currently? OK, cool. Wow, about half the room. This is a feature introduced in SQL Server 2012. And it's similar to failover clustering in that there's a dependency to Windows clustering. And it's interesting, Denny mentioned earlier about how SQL Server doesn't really, a failover clustered instance of SQL Server doesn't really interact with the Windows cluster all that much. It's interesting because always-on availability groups interacts with the cluster a lot more. As soon as you enable this feature in SQL Server, before you even build an availability group, as soon as you turn it on for the instance, it starts talking 5 times a second to the cluster to make sure everything's good with the cluster and not initiate a failover. We have a few different terms here. So Windows Server failover cluster, yeah, same as in our SQL cluster. Big difference, we don't have a requirement for shared storage. So unlike our failover cluster, we're going to have, instead of 1 copy of our databases, we're going to have 2 copies of our databases. Our core concept is an availability group, and that's going to be a group of databases. The example I always like to use, in the past we had database mirroring as a similar solution to this. That was 1 database at a time. If we had an application like SharePoint, and SharePoint's the one I like to use because a lot of people have it and it always has a ton of databases in it. We can group those 10 or so databases in SharePoint together in this concept known as an availability group. Those become known as availability databases, and they're all going to fail over as one in one group. We also need a virtual computer object for our listener name. In the cluster, we had a virtual network name, and that was how we connected to our instance. In an availability group, we have a listener. A listener is just a virtual IP address. We can still make local connections to our availability group instances, but the listener gives us some more intelligence, what we'll talk about later. Our availability replicas are known as replicas. We can also do reads on the secondary. That's really a key feature because you can get scale-out reading. And we'll talk about some more enhancements that have been made to this in 2016 because there were some limitations in the first couple of releases. We can take secondary backups. This is a feature that I've toyed with a lot and I haven't always used. It really depends. For sites that are geographically close together, it doesn't make a lot of sense. But I was on a call this morning before our session with a company in Holland that's doing an availability group between Holland and the US. And there it's going to make sense to take backups on both sides because in that case they're going to want to be able to, if they have a failure on either side, they're not going to want to have to ship 12 terabytes across the ocean. So it makes sense to take backups on both sides, but we have that availability option. One other thing I'll mention, Denny was talking about failover clustering, which is available in SQL Server Standard Edition. Up until SQL Server 2016, which we'll talk about at the end, always-on availability groups are limited to Enterprise Edition. So here's our concept. We have 2 data centers here, one in Washington and then one in Chicago. So when you do a cluster install, you're typically going to do a clustered install of SQL Server. These are 3 distinctly standalone instances of SQL Server. We can have a failover cluster instance involved in this. I don't for simplicity in this diagram. All 3 of these instances are available in our availability group, all 3 standalone. We can do multi-subnet here. There's no real trick to it except assigning the listener a second IP address. And we have that listener name that's part of our Windows cluster. One other key difference is you might manage your SQL Server, or you will manage your SQL Server failover cluster instance through Windows Failover Cluster Manager. Never touch the object in Windows Server, in Failover Cluster Manager for your availability group. SQL Server touches that, and that's it. You'll break things if you touch it. But so here we have 3 standalone instances, 3 nodes, and we have this concept of the availability group. The availability group can be up to 10 supported databases, and you can have up to 10 availability groups on an instance. Realistically, if your workload's a lot lower than that, you can have more databases in it than 10. I've done it before for low workload systems.
Yeah, it's important to remember that's a support limitation, not a hard stop. So you can put 1,000 databases in an availability group if those databases aren't doing anything, or if they're doing 30 transactions an hour or something like that. So you can play with those numbers. Just gets iffy when you call support and have to have them actually look at stuff.
Yeah, and one other thing to note is kind of from an internals perspective, Database mirroring was a single thread per database. With availability groups, we have this concept of a workload pool, and that's what does the transaction shipping. We also have synchronous and asynchronous replication. So in this scenario, we'd have synchronous between our two instances in Washington, and then async to Chicago. Generally, like anything that's async versus synchronous, the limit's around 100 kilometers or 60 miles or what, 20 milliseconds?
Give or take, yeah.
Yeah, give or take. So just like database mirroring, if you're in synchronous mode, a transaction won't be committed on the primary until it reaches the transaction log on the secondary. In async, you can queue up. So the concept I was working on today in Holland in the US, they're going to have 2 instances in Holland, and those are going to be synchronous. And then they're also going to have 2 in the US, and those are obviously both going to be asynchronous. So Windows cluster dependency and listener name dependency. So this is kind of different from mirroring because somewhere in different. Transaction log stream, it's going to use an encrypted endpoint. So you don't have to set up encryption by default. It's going to use, I believe it uses this. Actually, Ryan had this question for me the other day, and I forgot to ask you. Service master keys, right? If you don't, yeah. So this is encrypted by the service master keys. Our secondary replicas can be readable. We have some interesting scenarios with this. So Microsoft gave us the availability to scale out a lot, up to 8 nodes in 2014. That gets pretty expensive. We'll talk about that more in the next slide. But we have this concept known as read-only routing. You won't see this in the availability group's GUI, so I just wanted to tell you about it because it's not there. But also with the SQL 2012 client, in addition to the multi-subnet support, there's this concept known as application intent. And we can pass, there's read or read intent, I believe, are the 2 different ones. And you'll see when you're setting up your availability group, you have the option to select allow all connections, allow none, or allow read intent only. And if you allow read intent only, it will route any connections that have that intent of read. So you can handle all of your writes on your primary, and you can scale out all of your reads to your secondary, which is a really nice feature. One thing to note, as soon as you do still get, much like you do with failover clustering, you get 1 copy of SQL Server for free for DR if you have software assurance. Yeah, they threw that software assurance thing in last year. Thanks, Microsoft. However, the second you start reading it or taking backups on it, you do have to license it. Also, much like database mirroring, you have to have automatic failover in order to support synchronous, or you have to have synchronous replication in order to support automatic failover. Microsoft wants you to check that allow data loss box if you're async. So here was the sizing and availability for our availability groups. 4 secondary replicas in 2012. We could have 2 sync copies and 4 async copies. Apparently that wasn't enough for some clients. In 2014, we went all the way up to 8 async and then 2 synchronous. And we have TBD here for 2016, but I'll tell you, and we'll talk about it a little more later. The number of asynchronous copies has not changed, but we do allow 1 more synchronous copy, so we can have up to 3.
Well, if it has changed, it hasn't changed yet.
It hasn't changed officially.
Yeah, there's still 6 more months to go minimum before this is coming out, so they may still bump that up.
Yeah. Man, the testing gear on that's got to be pretty hard, though.
Yeah, they got a nice room about this size full of servers.
Yeah. I haven't. Have you run into anybody with more than like 4?
No, 4 is about the limit I've seen, but I know there are people out there that want more than 8.
Yeah.
There's like 10 of them. So.
Yeah, so basically if you're doing that, you're really doing it more for scale-out reading than you are disaster recovery. So like I mentioned, you can combine these 2 technologies. It does get a little bit messy because of the way the health check process takes place. The health check for clusters only can run at 1 level. So if you have a failover cluster in the mix of your availability group, a failover cluster instance, I'm sorry, you can't do automatic failover because that failover cluster instance is going to be doing its own kind of version of automatic failover at the health check level. Something else we didn't mention, that for 2012, for both clustering and availability groups, the health check changed for what initiates a failover.
Yeah, there's different levels that are supported. So you can figure when you want it to fail.
Yeah, you can actually have SQL Server failover on a deadlock if you were so inclined. I don't know why you would ever do that. But But so it does allow you to have additional redundancy at each site. The other nice thing about failover cluster instances, one of the big differences in managing failover cluster instances versus managing availability groups is in a failover cluster instance, our whole instance is protected. And what that means is all of our logins, all of our jobs, we don't really have to think about that because the instance is only ever running on one node. With availability groups, we have two standalone instances that just happen to be transferring data back and forth through an availability group. So we have to worry about syncing things like jobs and logins, and you have to kind of build logic into your jobs. And if you've used, there is some logic if you use the default maintenance plans, but don't use the default maintenance plans, please. We generally recommend Ola Hallengren's maintenance solution. He's also got intelligence built in, and I really like the code he's written for it to check to see, do I want to run this backup on the primary? If so, do this. So it's just something that you have to think about job management and login management more than you do in a clustered instance. That's really the biggest difference. So these are some of the other features that are mostly supported. Some of these are challenging. Most of them work. File stream and file table. Is anybody using? It's file table, right?
That's file table.
Is anybody using file table?
Oh, a couple people actually are.
Wow, awesome. Four people. So file table and file stream aren't supported. Column store indexes are supported in 2012 and 2014. In 2014, if you're using always-on availability groups and clustered column store indexes, you can read them on the primary, but you can't read them on your secondaries. Your secondaries are going to be in snapshot isolation mode, and that's why I have this asterisk here. And clustered column store indexes don't support snapshot isolation mode in SQL 2014. This was a problem. This is one of the reasons why we have a client in TAP. This is fixed in 2016. I don't know how they fixed it exactly, but it's fixed. Full text indexes are supported. You can do replication. There's a few hooks you have to do.
Yeah, so replication is, it should have an asterisk next to it because there's a sort of supported in availability groups. So the big caveat here, or the biggest caveat, is the distributor is not supported within an availability group. The only high availability solution for your distribution database is traditional failover clustering. As far as I know, there are no plans to change that in 2016. The biggest reason for that is the jobs. If you've ever looked at the number of jobs that are available on a dedicated distributor, there's a lot of them. I've got a client that's got a distributor that's got 30 or 40 publications, which means there's about 90 or 100 jobs running on that server that are all part of that replication topology. You can put your publisher or your subscriber within an availability group, works just fine. There's a couple of stored procs that you have to run to get replication to understand that the publisher and subscriber could be on any one of this set of servers. This is well documented in books online. You just got to go in and grab the names of the stored procs and grab the parameters. There's no GUI for it, unfortunately, but you can just run a couple of quick commands, and then at that point, when you fail over your publisher from one node to another, one replica to another, it will just fail over nice and smoothly.
So the other thing, and this helps solve not the jobs problem, but the user problem a little bit, if you're only using SQL users anyway. You can use Windows users with contained, right?
Yes.
Okay, yeah, that was added. So contained databases, this feature isn't fully implemented yet. I don't know if it ever will be, but it does allow you to keep users together with a database in your availability group. So that's kind of a nice feature. The other thing, since Denny was talking about replication, and we're not really in alphabetical order here, and I realize it's not on the slide, is anybody using SSIS DB for their SSIS catalog? Wow, I'm surprised it's that low. It's really wonky with availability groups. There are a few good blog posts from the SQL Cat team on it in terms of how to configure it. You can configure it, but you have to do things like restart when you fail over. I was talking to Matt Mason, who used to be the head of that program, yesterday, and he talked to the dev team last week, and I'll summarize it by saying there are enhancements in SQL Server 2016 to the SSIS process. They may get better in the future, but that's where they are. Policy-based management you can do across an availability group. Maintenance plans, like I say, I don't recommend personally using maintenance plans, but they do support availability groups, and there's even a checkbox, and there's a sys function that you can call that is called isPreferredReplica, and depending on where you want to run those jobs. So Some people, if you're under a really high workload, may want to offload backup to a secondary. And if you're doing that, you can specify that the secondary is your preferred place to take backups. So when that job runs on the primary, it's going to say, oh, this isn't the preferred replica to take this backup. And then it's going to just exit with successful. I forget the exit code it uses, but also auditing user-defined server roles, which was a new feature in 2014. You can use TDE, and you can use SQL Service Broker. I believe there are some enhancements coming to Service Broker in 2016, but I don't know what they are yet. One of the other really cool things you can do with this is do it in a hybrid model. So multi-site failover clustering, we can do in a hybrid model, but it really does require a lot of, we need third-party software, and it's not as well documented. In SQL Server, it can be as simple as a single click after your network and Windows admins have done all the hard work of getting your network hooked into Azure. Actually, good time for a poll. How many of you have assets in Windows Azure or Microsoft Azure? Okay, about 10% of the room. Okay. How many of you have corporate plans to get assets in Azure by the end of 2015? Okay, about 5-10% more.
A few more, yeah.
Yeah. Yeah, so I've been working on this scenario since 2013. It was really ugly then. There was a lot of like hand coding PowerShell. And I told someone building my first hybrid cluster, Windows cluster, was probably one of the hardest things I did in IT. Once your network is set up and your cluster is set up, this is as simple as setting up an availability group. So you can deploy one or more secondary replicas from on-prem. You're going to want to use asynchronous. You can get fairly low latency. There's a concept known as ExpressRoute, which is a dedicated network connection, which is what you're going to want. You're also going to want to choose your best region depending on where your users are. So obviously there are also political considerations, latency considerations. There's a bunch of things that have gotten added to this in the last several years that made it just a lot easier to do. Initially, when we started, you couldn't have any sort of a static IP. Everything was a floating IP address. That was really fun when you rebooted. Now we can make IP reservations within Azure. Also, initially, we couldn't go across data centers in Azure, so you're limited to having multiple network connections. Now we can have we can talk to multiple data centers. Another thing is now we can have 2 NICs. I haven't gotten that to work, but you can do that. You also have a low total cost of ownership. I like to, and there's a few, and this kind of goes beyond the scope of availability groups, but there's a few DR scenarios that you can do really on the cheap in Azure. You can back up your databases to Azure and just have maybe a database server and an app server there waiting, even powered down. And in the event of a failure, you still have a little bit of downtime, but not as long as if you had to call somebody like SunGard to bring you new hardware. So that's a pretty good scenario. And much like Denny was talking about, this is a little bit more detail on this scenario. So this is a 2-node on-prem cluster. Really, from your perspective as a DBA or a sysadmin, this isn't that much different than what you'd have if you were doing this just to your second data center. 2 things of note that you really need to have. There's a gateway in Azure, and that's going to be your VPN connection to Azure. And you need some sort of a VPN appliance on-prem. That can be site-to-site VPN, which would support a dedicated VPN appliance from Cisco or another vendor like that. Or ideally, it's going to be ExpressRoute, which is a dedicated connection that's low latency. They're relatively affordable, and a lot of hosting providers have them now. That's my preferred way if you're going to really implement this in a production environment. The other thing you can do, and I've blogged this a little bit, if you just want to play with this and learn how it works, you can, on your laptop, you can use point-to-site VPN. If you have an MSDN account, you get up to $150 a month in Azure credits. So you can kind of learn how this works by doing that. And point-to-site VPN is a certificate-based VPN. Once you get the cluster and the network built, that's pretty easy. You can click through the availability group wizard, and it should work. The challenging thing is our listener isn't a listener in the traditional sense where it's created through T-SQL. We have to use Azure PowerShell, not just regular PowerShell, so you'll have to go out and download it. Hopefully they include that in Windows 10. I really hope they do. And also you'll want to note that they update Azure PowerShell once a month. So even if you have it on your machine, you probably want to go out and get the latest version. And you create this internal load balancer as your listener. So instead of having just a regular listener, it's an internal load balancer to your Azure. And one other thing to note about that is those do take longer to fail over. Yeah, didn't you run into that with your cluster?
Yeah, so I ran into this when I was starting to build clusters about 2 weeks before they were officially supported because, like any good DBA, I want to break whatever I can get my hands on. When you're building your cluster or your availability group in Azure, when you build this internal load balancer, you have to tell it how often you want this internal load balancer to look and see which box is actually running the IP address that is your availability group listener or your cluster, your shared cluster IP. So it's not as simple as the IP comes up and then you can start talking to it. So you've got to wait about 10 to 12 extra seconds. So basically from the time SQL says it's online, clients are still going to be down for a minimum of another 11 seconds. And it's actually 16 seconds by default. So you want to change the number of probe intervals down to 2 from the default of 3, which is what's provided on the Microsoft scripts. But once you do that, things will come up. So this was a very fun set of phone calls I got to make at a very early hour in the morning, screaming at a lot of people going, why isn't this working? Because like any good DBA, I'm not very patient. So failover clustering said the IP was up, and I'm pinging away at it going, why isn't this working? And calling support and going, what the hell's going on?
And they're like, just wait 30 seconds.
Yeah, so it's literally just wait, give it a second, it'll come up.
Yeah. How many of you have secondary data centers? Okay, wow.
That's a lot more than I was
Three-quarters of the
expecting.
room. How many of you have tertiary data centers?
Okay, so those are the finance guys.
Interesting. So how many of you have one data center? Okay, this is for you. Finance guys, yeah, we'll sell you some licenses later. So why do you want to do this in Azure? It's a little complicated. Microsoft is making it a lot easier. Trust me, it's eons easier to do now than it was when they first proposed it. We have a gateway failure, some unavailability event. We don't have a DR site. Or like one place I worked, we couldn't. I worked for this medical device company, and we had a reasonable budget. They were a fairly successful company, but the only place we had people to manage data centers was 10 miles apart from each other. And they were in Pennsylvania, and I used to think that wasn't that big of a deal. I grew up in New Orleans, so like I've been planning for DR since I was born. But in Pennsylvania, I'm like, oh, we're not going to get hit by a hurricane. It's fine. And then we did. So it doesn't make a lot of people. Really, the hardest part of this is the ops. You have ops and you have site rent and maintenance, but you can get a rack and a colo for not a lot of money. Hardware is not terribly expensive, but licensing hardware is. And one of the cool things you can do if you're not really using your Azure secondary a whole lot, except for DR, is size it relatively small. In the event of a failure, you can size it up, so you're only paying when you need it. So to me, that's really the biggest benefit is the flexibility. It's really good for DR. It's really good for if you have flexible workloads, so if you have to scale out at some point during the year. So the client I'm working with right now, they're not planning on using scale out to Azure full time, but they may have, the way they work is they generate data sets for other companies off of a large data warehouse that they have. And they occasionally have the need to generate a large data set that they're not expecting that's beyond the scope of their hardware. So having the ability to spin up a really large, like G-Series VM, crank out a data set and then spin it down is a lot more cost effective. Where this isn't cost effective, and Microsoft's probably going to slap me for saying this, but I'll say it anyway. If you have large, consistently high workloads, the cloud just doesn't make sense economically yet. It's much better for low workloads and peaky workloads because server hardware is not that expensive. So this really applies for availability groups as well as hybrid availability groups, but we get integrated disaster recovery. One interesting thing is you can offload your read workloads to Azure, so connect Power BI, or if you have a reporting services instance in the cloud, you can do that. Potentially migrate some web apps or customer-facing apps to run against local secondaries. One thing I really like, and this is a feature you probably want to think about doing, maybe even if you're not using availability groups, is offloading your backups to Azure. Starting with SQL Server 2012 SP1 CU2, you really do have to apply those CUs now because they actually put functionality in them. We got the ability to back up to a URL, which is just an Azure drive, and we can send our backups directly there. Really nice feature for DR. I know a lot of you probably work in publicly traded companies that have offsite backup requirements, and sending tapes to a third-party provider always scared me a little bit, but backing up to Azure is a pretty nice feature. And starting with SQL Server 2014, you can encrypt your backups without turning on transparent data encryption. It's support. One other thing we kind of glossed over, and I don't think we even mentioned this yet, Windows, this is a limitation of Windows Server clustering. It's not really SQL clustering. All these scenarios that we've talked about require everything to be in the same Windows domain. You can't build a cluster across a trusted domain. The other thing I'll say is if you're doing any sort of a hybrid scenario, you want an Active Directory domain controller in the cloud, just because if you ever lose your connection, you want to be able to authenticate against AD. And Denny, tell me about sizing again. You don't want an A0, right?
Yeah. So when you're building your domain controllers, do not use an A0 VM.
To save money.
Yeah, I did this to save money for a client because they were going to have lots of domain controllers. And after 3 hours of trying to replicate Active Directory, I just gave up and turned off the VM. When I spun it back up as an A1, it took 8 minutes. So you can size it down to an A0 if you need to later, but make sure you use a larger VM size when you're actually spinning those things up.
Okay, so now for the celebration, and I'll hand back off to you for a bit.
Yeah, so apparently somebody at Microsoft got really drunk and decided they were going to let us tell you guys about all the new features before anybody else does. So we have a few new features in 2016 in availability groups. We have a new trigger that we can trigger every time a database fails over, so we can actually have SQL Server do something specifically when the database comes up, which is kind of cool. Probably one of the biggest things for large enterprises and for large application packages is the second one here, DTC support. So DTC is Distributed Transaction Coordinator. This allows us to run multi-server transactions. So I can start the transaction within my application code. I can do stuff locally. I can go to the database. I can do stuff. And it's all one transaction. Most importantly, it commits or rolls back as one atomic unit. Yes, absolutely. This is a huge thing that we did not have in SQL Server 2012 and 2014. We've got more automatic and better automatic failover support, so we've got more levels we can set as to what should trigger a failover of our availability group. We have even better performance when moving the transaction logs from one server to another. So the way the transaction logs move is basically just what we call a TDS stream. Server A makes a socket connection to server B and just starts firing transactions across that as fast as it can. Well, in a really, really high load workload environment, it may not be fast enough. They've now improved that. I don't know by how much, because they're still working on improvements on it today, and they will probably still be working on improvements until about 3 days before this thing goes to RTM.
We have a little bit more detail on this slide. Yeah.
We've got load-balanced readable secondaries. So this was really cool. So Joey talked about the ability to be able to scale out a little bit through read-only routing. And by the way, I've written a GUI for that that's available, so make it a little easier to configure than through T-SQL. So with the load-balanced readable secondaries, instead of just getting everything shot off to a single secondary server, because when you set up read-only routing in 2012 and 2014, all you do is just go from server A, everything gets sent to server B. If server B goes down, everything gets sent to server C to run those read-only connections. Now, we can do what I actually did in a pre-con at TechEd 4 years ago, which is load balance that workload across all the secondaries. To do this, you used to have to set up some sort of hardware load balancer outside of your environment to route all your connections. It was a royal pain. Now I can do it all through T-SQL, and SQL Server will handle all of it. And it's not doing any sort of performance metrics counting. All it's doing is just straight load balancing. But now instead of scaling on my application across 2 servers, I can scale out across 9 servers if I need to. 8 readable and 1 read-write. We've got support for the global managed service accounts.
Group managed service.
Group managed service accounts,
Yeah.
sorry. So this is huge, huge support.
How many of you have to change your service accounts passwords every month?
Yeah. Who actually does password management on production accounts?
Yeah.
who's supposed to do password management on production accounts. There we go. Okay.
Yeah.
So this will solve that problem.
Yeah.
You create a group managed service account in Active Directory. Yeah, do it through PowerShell. That's fine. You tell the Active Directory what machines are going to be in your group that are all going to use the same account. You configure SQL Server to run under that account. You do not specify a password. That's how when the app server knows it's a group managed service account. It will then run under that service account. The nice thing here is Windows will change the password automatically every 30 days and update that password on all the servers automatically without restarting services.
Yeah.
Yes.
By the way, that works on that works on older versions of failover clustering.
Yeah.
Yeah.
So most of the problems that SQL Server had with that were actually Windows issues that are getting addressed, and I think they're rolling some of those patches back into older OSs. Yeah. Who's using database mirroring today?
In Standard Edition.
In Standard Edition. Bunch of you. All right. Standard Edition support for availability groups as a two-node availability group cluster starting in SQL Server 2016. So the database level failover trigger. So this is going to be where things, how we determine things are going down. We're getting more support for how things are going to go offline. This is telling us the availability group health is now going to be monitored at the database level, not just at the instance level. So database level things can start to trigger failovers now, which can be a good thing if you need that for some things. Like I said, DTC support, fully supported in 2016. Currently, in 2014 and 2012, not supported at all. So obviously, this is a huge, huge change for us.
So this log transport performance, the call I was on this morning with Holland, I'm pushing them to get into the TAP program because of this change. So a couple of things here. 2012 and 2014 only supported one automatic failover target. Like I mentioned earlier, in order to support automatic failover, you needed synchronous replication. Here in 2016, it supports any synchronous target, so we can have up to 3 in our automatic failover pool. So that's pretty handy if you're in one of those environments like BWin or NASDAQ, where you have to be super highly available and in sync. That's pretty cool. The log transport performance, the problems Denny was talking about are mainly around clients that have super high I/O availability. So if you're running like a legacy SAN from a PC vendor that melts down when you throw any sort of I/O at it, you probably don't have to worry about it. But if you're on like one of these new super fast SSDs or SSD SANs, throughput can be a lot higher. CPUs have gotten faster. Solid state's made our storage get a lot faster. So typically in the past, when they'd make changes to this, the team at Microsoft would compare the performance improvements they'd get from, say SQL 2012 to SQL 2014. They'd compare it to the same release. So they'd say, hey, look, we made log transport 15% faster than SQL 2012. The performance aim with this log transport performance is to make it match a standalone server. So they want it to be as minimal as possible. My guess, and I haven't talked to Kevin about this in detail, is that they're compressing a little bit more because the stream is compressed now, but it's not aggressively compressed. And I feel like, especially with as powerful as CPUs are now, you can be a little bit more aggressive with compression.
Yeah, so here is the slide on the readable secondaries and how the round robin works. So back in the good old days, back in 2012 and 2014, all these clients would connect to the availability group listener, and they would all be sent from the primary machine to a single secondary. But now we can actually spread that workload out across all the boxes. So it gives us a much, much more scalable workload, a much more scalable environment. So we can now handle really, really big workloads. And keep in mind, we can do clustered column store on this as well now in SQL Server 2016. So if you've got really ridiculous data warehousing performance requirements and report requirements, we can actually support those fairly easily, and we'll call it inexpensively, compared to other database platforms that are in the greater San Francisco area. Just to be clear. So we can support that fairly easily by scaling that workload out across
they have
multiple
column store
boxes.
now too.
Yes, they do.
It's only 25,000 extra CPU.
Oh, is that all?
Yeah,
That's very inexpensive compared to buying a Tesla for every CPU.
So group managed service accounts, Denny talked a little bit about this. Especially for those of you who are sysadmins, if you check out my blog, joeydantoni.com, I have a link to somebody else who's a Windows sysadmin to set this up. There's a couple of things you have to do in AD that are pretty minor. We did it at Comcast. I don't know if Tim's in the room. He's around at the conference. But we did it on a Thursday afternoon. So he knows more about Active Directory than anybody I know. He wasn't too worried about it breaking anything. You do have to be, I think, on a 2000, your domain has to be on a 2008 R2 functional level. And you're adding like a 2012 feature to it. So this is a really cool feature. It started being supported in 2014. At first, they just said it was supported. And then I blogged about it, and I got like 5 emails from Microsoft saying, hey, look, my availability group falls over when I do this. I really like the feature. It's really great. So this has been, managed service accounts have been around for a while. I think it was 2008 R2, right?
Yeah, that's when it was first introduced.
But when managed service accounts were first introduced, you could only have a relationship of one managed service account to one server, which is fairly painful to manage. It's just as easy to manage service accounts. So now with group managed service accounts, the way I'd probably implement this, unless I was in a super highly regulated shop, would be to have a service account for prod, a service account for test, and a service account for QA. Assign all of my SQL servers in that environment to that service account, and then just let the service accounts be managed. You will see a password when you configure it. It's coming from AD. You don't have to enter it. You do have to expand. When you're selecting the service account, you have to expand the browse box to look for managed service accounts. Like I say, I have a blog post on it. It really hasn't changed for SQL 2016. It's just supported for availability groups. That's really the big difference. But it's a real. Oh wait, I have it on the next slide.
Yeah, so you got a picture.
Yeah. So this is what it looks like, and this was on a failover cluster instance where it worked. So you'll see the password. Don't mess with it. And that's kind of what it looks like. It's going to be GMSA1 $.
Yeah, so the $sign is important. Without the $sign, it thinks it's looking for a regular user account. So the $sign is what tells Windows, hey, this is a managed service account.
Yeah, and I don't have this screenshotted here, but in that browse box where you select users, groups, or
computers.
Computers. Yeah, you'll expand that and select service accounts. I'll let you make the standard edition introduction.
So obviously, the availability of availability groups in Standard Edition, kind of a big deal. We've only been waiting for this for like 4 years. So obviously, it's Standard Edition. There's some limitations. So it is only going to be 2 nodes. So but that's fine. That's basically what we have today with database mirroring. Whenever I was over in Redmond kicking whoever I needed to kick to try to get this to happen, I just always told them, look, we need just a replacement for database mirroring that's going to be supported moving forward, that's not going to get deprecated quickly. You can have multiple availability groups, but you only get one database for availability group. So the same basic concept we have in database mirroring. Everything fails over, all the databases fail over independently. Some things I'm not real fond of, we don't get readable secondaries, and we can't take backups on secondaries either. So all that workload has to stay on that first box. So this is only an HA solution. It's not a scale-out solution. And I can understand why Microsoft made that decision, even if I don't really agree with it, but I don't work there, so they don't ask me, and they don't have to do what I tell them to. We can take database snapshots, just like we can in database mirroring. So if you haven't done this before, if you need to do reading off of your secondary in database mirroring, or sorry, off your replica in database mirroring, you can take a snapshot of the database and go run point-in-time reports off it. It's not an updating database. It's just a static copy. We can do the same thing in the standard edition availability groups. So basically, this is database mirroring with the faster transaction log transport that Joey was talking about
Yeah,
earlier.
and this is all the detail we have. So with database mirroring currently, you can only, well, it's not called synchronous and asynchronous there. It's called high performance and high safety. So high performance is async. And the older versions, high performance was limited to Enterprise Edition. These were the notes we got.
Yeah.
We just made them pretty. So I don't know if Standard Edition is going to be limited to asynchronous.
And frankly, Microsoft probably doesn't either, because whenever they do testing in the TAP program, it's all Enterprise Edition.
Yeah.
They don't deal with Standard Edition until about a week before RTM. So they'll figure that out at some point.
Yes, somebody will alert them.
Yeah.
The other thing I'll say, if you need a scale-out Standard Edition solution, think about log shipping.
Yeah.
It's always going to be there. They're never going to be able to take log shipping out of the product because you can write it yourself. And it works pretty well for scale-out reads or replication. How many of you have a DR plan, by the way? Wow.
Wow. All right.
We got the good students.
Yeah, apparently.
Yeah.
Normally, there's not very many hands up when we ask that question.
Yeah, usually it's about a third of the room. That was about half. So understand your business needs before designing an HA and DR strategy. I always, when I was a DBA, it's also some career management though too. So I say this, and managers, cover your ears for a second. DBAs, I know you probably want to learn like always on availability groups because it looks really good on your resume. You probably don't want to put that on like your monitoring system. But it's a good way to learn it. So if you're in a big company, you can get away with stuff like that. If you're in a company that's counting licenses, it's a little harder. Always, DR is like buying insurance. You don't really need it till you do, but it's important to have. And SQL Server gives us a ton of good options for HA and DR. Today we mainly talked about availability groups and failover clustering, but there are plenty of other options like replication and log shipping that you can do on a much cheaper basis. And then always have a plan. And then Microsoft let us make one more announcement today.
So I pulled this off Twitter literally 5 minutes before the session started and threw it in the slide deck because, well, why not?
So hopefully they have more buses next year.
Yeah. So we've got a couple of minutes left in our session window. So I'm going to throw the eval slide up if anybody does want to take off. If anybody has any questions, we do have microphones here. Feel free to stand up in front of the audience. And if not, we will talk to you afterwards.
Yeah.
Well, thank you very much.